Hi, this is one spec or feature that's not often mentioned. That is unbalanced currents and balance. In other words, do the antennas have proper balancing? Again, that is actually important. Let me show you why. What do people mean by unbalanced currents? If we look at a dipole antenna, that's always the best example because it's a balanced antenna. Okay, you've got a current that would go to a peak in the middle and down. But remember, that peak, one of the currents go here and one of the currents go here. Now, if you could have inserted this magic little thing called an oscillator in the middle, that would be balanced, eh? But what happens in real life? In real life, we've got a coax cable here. And I'm drawing the coax. This is the outer of the coax. And there's the inner. And we have to choose, put the inner there and the outer to that. Now, the moment that happens, and that's why coax is called an unbalanced cable, the currents, I'm just going to draw the outer like a thick thing because it's got an inside and an outside surface. And we draw the inner, imagine that we can see through it. And this current here, we could call I1 and that one I2 plus I3. And I1, say in this direction, by transmission line behavior is always equal to I2. So I1 equals I2. That's great. That would have given us balanced currents. But this guy, some of the current can leak to the outside and run on the outside of this cable. And that would be I3. Now, if there's an I3, then suddenly we don't have this beautiful distribution. Now we've got this guy here and this guy here. Problem number one, dipole is no longer behaving like dipole, impedance will get messy. But the real problem is this guy here now also radiates. Okay, these two inside are hidden, nothing can see them. That's why it's called a shielded cable. But this stuff running on the outside will radiate. So if you go and do a computer model of that antenna, you'll actually have this, and there will be currents. That current I1 plus I2 on this guy, I1 here, I1 plus I2, and there will be I3 here. Now, messy, hey, because this cable doesn't necessarily go nice, you know, you've had coax yourself, it could be doing this, whatever, and interfere with this in some unpredictable way. You touch this, for example, the whole antenna performs, look, and doesn't behave. So you need to put balance in when you feed with unbalanced transmission lines, and all our transmission lines we use is unbalanced. And the way you do that is you include a device here, and I'm not going to discuss the type of devices that stops these currents. It could be the ferrite beads, it could be clever little circuits, but you need to stop this. Now this is not mentioned in spec sheets, but if you don't do it, you've got an antenna that could behave different depending where you mount it on, depending whether someone walks past it. Very temperamental and typically not working at all. The moment you put a balun in, which is essentially a device here that's got a high impedance. After all, the impedance, many people will just know it as resistance, but it's slightly different. Must be very, very large. Okay. Then the currents here can't flow. It is necessary. Our engineers design antennas like that, but you would find it difficult to go look at an antenna and tell whether it has got proper balancing. What you can try to do is just touch the cable, and if you see signal strength change, you know that you've got a gunky antenna, but you won't see that on a spec sheet.